We're going to try this again, or not again. We're going to keep going. It got cut off. I got a 10-minute limit, so I'm going to have to monitor my time a little bit better. And I will try and make sure that it all works for you, and I'll see what kind of variations I can do on software. All right, so here's an example of using these absolute value bars to try and solve a problem. So you've got these absolute values involved here. I'm going to move over to the document camera again because that does seem to be working pretty well on my end anyways. You'll have to let me know if there's issues on your end with that. So if I go back to my document camera, those absolute value bars are saying how far from 0 is negative 11. Well, negative 11 is 11 away from 0. How far from 0 is 8? Well, 8 is 8 away from 0. So absolute value of 8 is 8. This one, I've got this grouping again here. I have to do what's inside the absolute value bars first. So 3 minus 5 is going to give me the absolute value of negative 2. So before I can take the absolute value of 3 minus 5, I have to figure out what 3 minus 5 is to evaluate that. Now I can say, or I can ask, how far from 0 is negative 2? Well, negative 2 is 2 away from 0. So I can now subtract after taking the absolute value, but you can't take the absolute value until you have one number in between those absolute value bars. So you can ask the question, how far from 0 is that one number? You can't take the absolute value of 3 and the absolute value of 5 separately here. You need to subtract first. So now 11 minus 2, I'm going to read from left to right. 11 minus 2 is going to give me 9, and 9 minus 8 is going to give me an answer of 1. So that's how we evaluate a problem using those absolute value bars. Going back to our presentation here then. So that's absolute value. A couple different properties. Most of these you're very familiar with already. The commutative property allows us to flip-flop numbers, so to speak, that a plus b is the same as b plus a. X times y is the same as y times x. It'd be like saying 5 plus 2 is the same as 2 plus 5. They both equal 7. 5 times 2 is the same as 2 times 5. They both equal 10. So absolute value bars don't really change much. I apologize. Commutative property just allows us to flip the numbers around. I'll let you pause and write those down if you need to. The associative property allows us to group things in different ways. When you associate with somebody, you're in a group with that person. So the addition and multiplication, again, if you add 2 plus 5 and then add 7 to that, you'd get 14. If you add 7 plus 5 and then add 2 to that, you would get the same result. So no matter how you group this, you get the same result. Same thing with multiplication. So the associative property works by saying we can multiply things in different orders and we still get the same result. We can add things in different orders and still get the same result. Subtraction and division do struggle with these though. So subtraction with the associative property, the commutative property, subtraction doesn't work. And here's an example of that 3 minus 5 is not the same as 5 minus 3. So you can't flip-flop, you can't use the commutative property on subtraction. However, there is a way around that. This is called the inverse property, the additive inverse. It says that instead of 3 minus 5, we could change minus 5 to adding a negative 5. So 3 minus 5 is the same as 3 plus negative 5. Why that's useful is if we do want to flip these around, if we do want to interchange the 3 and the 5, we could change it to add a negative 5. Once we have that addition, then we can use the commutative property and say 3 minus 5 is the same as negative 5 plus 3. And so this is just a technique or a way that if you wanted to rearrange this for whatever reason, you could, if you change the subtraction to adding a negative. Here are two examples on the bottom here. If we have 6 minus 17 plus 2 minus 8, and for some reason or another we needed to flip some of these around, we could change it to 6 plus negative 17 plus 2 plus -8. Once all those are changed to addition, then we have free reign. We can use that commutative property. We can flip-flop any of these around, in any order we want, and get a result, or the same result. The reason I'm using this other example on the right here is this 9x minus 8 in parentheses is a grouping. But we can rearrange things around that grouping too. By changing this minus 5 to a plus -5, we could flip-flop the 9x minus 8 and the -5. As long as we keep that grouping intact as a grouping, you can rearrange that group wherever you want with that addition, with that commutative property. So again, I'm not going to test you on rearrange this in a certain way. It's just I want to make sure that you know these properties so that we're able to do it later on when we need to without having to go back and relook at it. Division. Again, commutative property does not work with division. However, an example here then, 3 divided by 5 is 0.6, I think, as a decimal, is 3/5. It's not the same as 5 divided by 3. 5 divided by 3 would be 1 and 2/3, 1.6 repeating. If you do want to rearrange division, one way you can do that, or one method, would be to change division, divided by 2, to multiplying by a fraction, multiplying by a half. 8 divided by 2 is 4. 8 times a half is 4. Half of 8 is 4. The reason that you might want to change a division into multiplying by a fraction is so you can rearrange it. Similarly, if it was like 9 divided by 3, 9 divided by 3 would be the same as 9 times a third. Divided by 3 is the same as 1/3. Divided by 2 is the same as 1/2. And so you can use that technique to rearrange numbers a little bit and to kind of avoid the issue of commutative property. The issues that commutative property doesn't work with division can be avoided if you turn it into a multiplication problem. Okay, distributive property. I'm actually going to pause it with this distributive property. I'm going to have you pause, you can write this down, and then we'll do some examples. That way I don't get cut off from my timing, and I'll actually have to make a third video for this one. So I'm going to pause it, you write these down. This is the distributive property, and then we'll use this property in some examples.